Maddie McCall watches your videos.
Oh, that's right at the beginning.
I know, that's why I said
You gotta do it in between.
it.
Thank you, Maddie, for listening to my videos.
She's gonna pay me for that. She's gonna hate me so much.
That was Dane. D-A-I-N. Dane.
She knows who I am.
Okay, unless you had another friend named Dane. I don't know.
I've
Okay.
never-
No, the guy with the purple vest is also an idiot.
All right, so today we are going to divide. All right. Thankfully, y'all are not my Common Core babies. Okay, you were not raised on weird division just yet. They're going to be coming up soon, I'm sure. So we're going to be doing long division. First, we're going to take a trip back to elementary school. Woo. Yep.
My favorite.
Without a calculator. I want you to divide this.
Oh.
Let's go.
Without a calculator, divide this. As I'm sure a lot of y'all have heard, parent night will be maybe tomorrow night. Unless it rains because it's outside. So just kind of give your parents a heads up. If it rains tomorrow, which it is an 80% chance, then it'll be moved to Wednesday. But it'll just be outside and they'll be able to come talk to me if they have any questions or whatnot. I think it's from 5 to 7. I think.
No one's doing that. 5 to 7 outside with the possibility of rain.
80%.
Well, if it rains, that's where I'm at.
Still, I mean, like, that's my point. Like, people don't want to be there, and then it starts to rain, and they gotta go home.
Okay, so you might have been taught a certain way, certain language to use when solving these. You might have had a different method or something like that. I'm going to say it the way that I learned it-ish, / what I want y'all to be able to use the same lingo when we do polynomials, okay? So it might sound a little bit weird compared to what you have said in your head when you were working through this problem, but I'm trying to train y'all to when you do the polynomials, okay? So first thing you probably did was you probably asked yourself the question, okay, 41 goes into 86 how many times? Or you might have said, what times 41 gets me close to 86, okay? Me personally, and that's why I'm getting you close to doing polynomials, I look at the first term and I say 4 times what gets me 8? 2, right? So then 2 times 4 gets me 8, and 2 times 1 gets me 2. Now, again, that's weird to say, so just roll with it. Then we subtracted, all right? Another way to say this is I'm going to draw my line and change my signs. I don't know if your elementary school teachers did that or not. And then I add straight down. So I end up with a 4, and I'm going to bring my 9 and my 3 down. Okay? Then I start over, and I say, okay, well, how many times does 4 go into 4? Once. So 1 times 4 gets me 4, and 1 times 1 gets me 1. Draw my line, change my signs. I end up with 83. 4 times what gets me 8? That's 2. 2 times 4 gets me 8. 2 times 1 gets me 2. Draw my line, change my signs. And what was that called? Remainder. Okay? Now, you probably wrote a little cute little R, and then what is it? A colon, semicolon, dot, dot. What's the dot, dot?
That's a cool. That's a cool.
That's a what?
A colon.
Okay, thank you. I don't know English. Okay.
Colon.
So we're not doing that here. All right. What we are going to do is we're going to take our remainder and we're going to put it over what we divided by, because it didn't go into it evenly. Then we're just going to put it over it. So our final answer is 212 and 1 over 41. Okay. That's how we're going to write our answers. We're no longer going to put the cute little R off to the side. Okay.
So that's the way you want us to do it?
That's how I want the answer to be written. Yes.
Well, no, I mean like that's how you want us to do it.
Oh, long division? Yes. Because here's the thing. We're going to be doing variables here in a second. So I tried to use the same method of madness.
Like, sort of did that, but like the other way. It kind of brained it.
Okay. So let's add variables into this. Write this down, and we're going to do this a bunch today. Write this down, then put your pencil down. Okay, so the reason why I have y'all put your pencils down is because y'all are so used to playing school. I gotta get down what she has written there, okay? By the time you look down and look back up, I'm on a completely different step, okay? Especially when we get to synthetic division. As soon as you look down and look back up, I could potentially be done with the problem in general, okay? So I want you to watch. It was like a y'all and a you mixed in there. I want y'all to watch so that way you can actually see what's happening here. Okay. So just like the last problem, I'm going to ask myself the question, what times x gets me x to the 4th? X to the 3rd. Thank you. Because then I can say, well, x cubed times x gets me x to the 4th. That's the whole purpose of what we're doing, because we want to be able to subtract and have the same exact thing right there. Okay? So I also multiply the x cubed times the -2, so minus 2x cubed. If you want to use different colors, that's a good idea for this one, just because when you now draw your line and change your signs, on your notes, if you're using the same pencil, you don't know what just happened, okay? So I know it's tempting, just don't use your pencil just yet, okay? So if I add straight down, that's gone, and I get 5x cubed, and I'm going to bring everything else down with me. Now I start over. What times x gets me 5x cubed? 5x squared. 5x squared times x gives me 5x cubed. That's what we want. 5x squared times negative 2 gives me negative 10x squared. Draw my line. Change my signs. That gets me 0. Now I end up with 8x squared plus 5x plus 1. Let's start over. What times x gets me 8x squared? Huh? 8x. So 8x times x gets me 8x squared. 8x times negative 2 gets me a negative 16x. Now, the longer problems, you're probably like, oh my gosh, this thing's still going. These are the good problems for this because you find yourself doing the pattern over and over again that you kind of catch on towards the end, okay? Draw my line, change my signs. So I get 21x plus 1. What times x gets me 21x? 21. So then I'm going to scroll down for just a little bit. 21x and then minus 42. Yeah, 42. And my last draw my line, change my signs. I end up with a remainder of 43. So how would I write my answer? I would write everything at the top. So x cubed plus 5x squared plus 8x plus 21 plus 43 over what I divided by, x minus 2. So it's the same exact way we wrote our answer before, but now we have a polynomial, okay? So yes, that is a lot, but that's why I wanted to make sure you watched it, okay? So if you feel like that made sense, try to do it on your paper without looking up. But if you're like, I have no idea, I need this on my notes anyways, you can go ahead and copy it down, okay? Go ahead and pick up your pencil and you can either try to work it out yourself or you can just copy it down.
Do I need to do that sheet or will she, and then we'll do that? I'm gonna get back to you. Okay. Do what? Is she gonna be there then? Okay. That's very soon.
After working through these, does anyone have any questions on it? Where I'm getting numbers that I'm getting, how am I doing what I'm doing, all that nonsense? And some of you are still working through it. Just a heads up, as of right now, I'm hoping, as of right now, your next test will be on Friday. I'm hoping, but we'll see. Make sure we're all on the same page with a lot of this stuff before we do that. Hey, does anyone still need a minute of this? And as always, I post these videos on Canvas if you need to reference them later, and whatnot. Okay? All right, let's try one on your own. It's shorter, which is nice. See how far you can get without referencing the last problem. You're in there. We just have to choose how to log in and all that stuff. But yes, you are in there, which is good. Change my font. You don't like my font? That's very cute and scripted. You didn't like my font. Get it? It's fine. Okay, so like I said, same language that I've been using on all the problems. I'm going to continue doing these. What times x gets me 2x squared?
2x.
2x. So I take 2x and I multiply it to x, I get 2x squared. I also do 2x times 3, that gets me 6x. If you are not changing colors on your notes, but you still want to denote if you've changed a sign, you could easily just write a minus sign above it and circle it if you want to do that. Okay. If you do have a different color, that's great. It makes it easier. So we get negative 10x plus 3. And what times x gets me negative 10x? Negative 10. Negative 10 times x gets me negative 10x. And negative 10 times 3 gets me negative 30. Draw my line, change my signs. I get a remainder of 33. So I take what's up at the top, 2x minus 10 plus 33 over what I divided by, which is x plus 3. Now I had a student in 7 a.m. ask the question, can I reduce the 33 and the 3? No, okay? Do not do that, okay? It's just like when I taught y'all Dorito chip with the quadratic formula, okay? If all 3 pieces are divisible, then yes, you can divide. But aren't we dividing here? So if I'm having to do more work at the end, I didn't do my job on here, okay? So there should be nothing you have left to do once you get your answer. All right, once you get your answer, you're done. All right. Any questions on long division? Now, long division is only if you have to do long division, okay? And when you have to do long division, if you have something other than a linear, remember, x raised to the first power, a linear binomial. If you have something other than a linear binomial, you have to do long division, okay? So if this was x squared, I'd have to do long division. I can't do synthetic that we're about to learn, okay? Can I do long division for every single problem? Yeah. Do I want to? No, okay? But I can do long division for every single problem, but I can only do synthetic division of a linear binomial, okay? So, what is synthetic division? Let's go ahead and write the same problem we did at the beginning of class today. Well, not the elementary school one, the next one. Same problem we did. Once you have it written down again, you can put your pencil down. Okay, so there is a reason why people call synthetic division short division, because it's real short. Okay, it's quick.
Call it fake.
You what?
It's fake division.
I've also heard that it's witchcraft. So,
Cade can do it. His mom won't let him do it.
all right. So, first thing you're going to do is you're going to look at what you're divided by. If I was to set that equal to 0, what would I get? Don't pick up the pencil. 2.
More secure.
Okay. So you put 2 in this little box here, half of the box, and then I'm going to list off all my coefficients here. Here's the trick. If you do not have all of your variables represented, you have to put a placeholder of 0, okay? What do I mean by that? If I have x to the 4, I better have x cubed, x squared, x to the first power, and a constant. If I don't, I need to put a 0 in that place, okay? If not, it's going to mess it all up. So if I didn't have x squared here, I would put 1, 3, 0, 5, 1, and so on, okay? So make sure to not forget, and you'll do it for long division as well. Okay, so this is how quick it happens. The first thing you do is you bring down the first number, no matter what it is. Always bring down the first number, okay? If I'm down here, I'm multiplying. If I'm up here, I'm adding. Okay, here's how quick this goes. What's 1 times 2? 2. 3 plus 2. 5 times 2. Negative 2 plus 10. 8 times 2. 5 plus 16. 21 times 2. 42 plus 1. Huh. Looks familiar, huh?
It is witchcraft.
You can't be here. You gotta get it.
All right. So that's exactly what happened here without all this. Okay. So let's look back through that for a second before you write it down. So I take what I'm dividing by, set it equal to 0, and I put that in this little box here, little shelf. I list out all of my coefficients. I bring the first number down, and then it becomes multiply, add, multiply, add, multiply, add, and so on, okay? So if I divided x to the 4th divided by x, remember your exponent properties? When you're dividing, what do you do to your exponents? You subtract them, okay? So this would simplify to x cubed. Well, now that we know that, all you have to remember is I just take 1 degree less here. So I would start with x cubed, x squared, and x. So then, just like the other answer, I would write down x cubed plus 5x squared plus 8x plus 21 plus 43 divided by x minus 2. Whole lot faster. Okay, go ahead and have that in your notes. If you want to try it on your own, like I said, go for it. You know what the answer is. See if you remember the pattern. If not, copy it down. You still have to write out your answer. You can't just leave it in the last line. You still have to write it out. But you don't have to write the x cubed, x squared, and stuff like that on the last line there if you don't want to. But you do have to write out your answer. Okay, so it's quick. Why some people call synthetic division short division. Any questions, again, on where am I getting numbers, how am I multiplying, any of that? Yeah.
What would happen if you were to try to do this without a linear binomial?
You cannot do this without.
Well, that's what I'm saying, like, why doesn't it work?
You would get more than one.
So when you set it equal to 0, you wouldn't have just a number inside here. So if I gave you x squared plus 7, are you going to put in plus or minus the square root, or I square root of 7?
Probably not.
I wouldn't either. So with it being synthetic division, the whole purpose of it is that it's quick, is that it's something, a linear binomial. And some books and some teachers stay away from even having a number in front here. That just means you're dealing with a fraction. Is it ugly? Yeah. Will it work? Absolutely. So you can still do, if this was 3x minus 2, you would just have 2/3. And it would still divide out like it's supposed to. Or if you want to do long division, that's fine too. Okay? So, just like before, we've already done this problem. You already know the answer is 2x minus 10 plus 33 over x plus 3. Okay, I had to look. Use synthetic division, see if you get the same answer. Remember the first thing you check, do I have all my variables? If I started out with x squared, I better have x to the first and a constant. In this case, I do. Okay, so if you're someone that's still confused, watch. If you're someone that's good, just check for your answer. Okay, so 2 times -3 gets me -6. Add straight down, I get -10. -10 times -3 gets me a positive 30. And the last one is always going to be my remainder. Okay, so if I started with x squared, I'm going to start with just x here. So 2x minus 10 plus 33 over x plus 3. Any questions on synthetic division so far? Okay, let's take a quick break. And we're going to figure out why we learned this. Okay, why did we learn how to do synthetic division? Usually what I'll do is I'll give them a break about part of what this is your time to do whatever, just kind of let your brain just relax a bit. Don't forget to submit last night's homework for those of you who haven't turned it in yet. Jeff, where were you all in your class?
We were doing this.
Were you? So have you learned this already? Okay, cool. You haven't taken a test on this yet, have you? All right. And I got your grade from the other stuff. So have you done quadratics?
Started with.
Okay. All right. We'll see if there's anything missing along the way.
Okay.
All right, let's go ahead and come back. All right, so why did we learn division in general of polynomials? Why are we doing synthetic division? There's a reason, okay? So let's first talk about quadratics for a second. The whole last 2 chapters we've done. How many answers did we get every time? 2. Okay. What was the highest degree of a quadratic? 2. That's convenient. That's the same number. Okay. So looking at this example, how many answers do you think I'm going to have? 3. So the highest degree tells you how many solutions you're going to have. Okay? The highest degree tells you how many solutions you'll have. So if I look at this one, 3 is the highest degree. I better have 3 answers. All right, so good news. They gave me 1 of them. I'm missing 2. Okay? Synthetic division allows me to break this equation down to a quadratic, and then I can find the other 2 solutions. Because that's everything we did in that last chapter. Okay? So for example, we're going to do synthetic division using that 1. I have to make sure I have a representative from each exponent. I've got 3, 2, 1 constant, so I'm good. If I did not have to put a 0, so go ahead and do synthetic division. Notice how the question gave you x equals 1. That's different from when I told you x plus 3 or x minus 2. Okay? I tell you x equals, you just use that number in synthetic division. Here's the beauty of these problems. If you do not get a 0 for your remainder, you did it wrong, okay? You did not get 0 as a remainder, you did it wrong. They are telling you this is a 0 of the function. This works. And if you don't get a 0 as a remainder, you did something wrong, okay? Now, we divided. It was x cubed. Now it's x squared. So x squared minus x minus 2. If I am missing 2 answers, I think I'm going to find them because we did 2 whole chapters on this, okay? How can I find my last 2 answers? Do what? Factor it. Thank you. Factors of -2, they give me -1. Got zombies in the class today. Okay. So if we set those equal to 0, we get x equals 2 and x equals -1. So I look at my highest degree. It tells me I should have 3 answers. They gave me 1. I found the other 2. Okay. Questions so far on that? What if you can't factor? X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. It's back. Okay, so other good news is that I am going to give you enough zeros to get it down to a quadratic. So if I am telling you it is to the x to the 3rd power, I'm going to give you at least one that's going to break it down so you can get a quadratic. If it's to the 4th power, I'm going to give you 2 zeros. And we're going to do an example like that. Okay, so go ahead and try this one out. Find my 2 missing zeros that I need here. I'll give you x equals -2. Sometimes it's hard, especially when you get something out. The negative gets lost. Remember, if you cannot factor, use a quadratic formula. Every single one of these problems are doable. Do they take forever? Sometimes. Is there a lot of steps to them? Absolutely. But it's everything you've learned up to this point. Did anyone realize before they started the quadratic formula that you could reduce this a little bit further? Okay. If you didn't, it doesn't matter. If you didn't notice that I could pick out a 2 or a -2, that could have made your life a lot easier in terms of simplifying. But at the end, you'll still be able to simplify. Okay, so I'm going to stick to what's up there. But if you simplified, you should still get the same answer. Okay, so we've got the opposite of b squared minus 4 times a times c, all over 2 times a. If y'all remember from last chapter, we work with what's inside the radical, okay? And if I was to plug what's inside the radical into my calculator, I should get 224. Then from the last chapter, I had to reduce radicals. So if I take 224, unless you know a perfect square that goes in there, just start dividing. So if I divide by my prime numbers, if I divide by 2, I get 112. If I divide that by 2, I get 56. Divide that by 2, I get 28. 2, 14, and 2, and 7. Okay. How many pairs, or I guess, so let me just start over there. I have a pair of 2s. I have another pair of 2s. So now I get 8 plus or minus 4. The 2 times 7 has to stay inside, so square root of 14 all over -20. And one last thing to remember is Dorito chip. Like I said, I wasn't lying when I said there was a lot of steps to these. All kinds of room for little mistakes. Okay. So if I divide all of those by 4, I should get 2 plus or minus the square root of 14 all over -5. Now, those of you who may have simplified, you might have had -2 plus or minus the square root of 14 over 5. That's okay too. Phew, that was a lot. What questions do you have? Yeah.
So, why do you divide the equation by the solution?
Why do I divide the equation by the solution? Okay, so what's happening is that if I gave you a question, just like we were doing a second ago with x squared, was it minus x minus 2 or whatever? And we said our factors were x minus 2 and x plus 1, right? So I'm multiplying to get this, right? But what if I only give you this and I want to know what this is? How do you undo multiplication? Dividing. So what we're doing is we have higher degrees than just squares. That's just a little bit more easier to grasp. But what we're doing is we're finding the rest of the solutions to the problem. So I'm giving you one of them. It's up to you to find the others. Does that make sense? Good question. Any other questions? Good morning. Nothing like a Monday morning just back in your face. Okay. So, like I said, I will always give you enough zeros, or you'll have your calculator, but I'll always give you enough zeros to take this down to a quadratic. Okay? So what if I give you 2 zeros? Does it matter which one I start with? Nope. Okay? I'm going to start with 0 first, only because it's the first one there, and I don't want to forget it. What's missing in my polynomial up there? The constant. So I need to put a 0 in that placeholder. Okay, so go ahead and only do synthetic division with 0 first. Since we don't have a constant, I have to have a placeholder for it. If not, it won't work. Like I said, if you did not have the constant there, you would have stopped at 4 and said, well, wait, my remainder is 4. This can't be right, okay? But with the constant being there, we do get our remainder of 0. So we have taken this from x to the 4th now to x cubed. I can go further with that, okay? So you're going to take your second 0 that they've given you, and you are gonna do synthetic division again to the new numbers you have. Okay? You don't want to go back to the original, because if you go back to the original, you're just going to take it back down to x cubed again. Our whole purpose is to break this down to a quadratic. So the 0, the solution 0, took us down to x cubed. Now 2 is going to take us down to x squared. And go ahead and find my last two solutions. All right, so if I end up with negative 47 on the inside, then all I really have to worry about is taking out that negative and making it an I. So 5 plus or minus I square root of 47 all over negative 18. So every problem except for this one, if I had a calculator, I would have found those answers on my calculator, okay? Especially the first ones we did. We would have ended up with that. Now, if we were to plug this into the calculator, we would not have found these last two imaginary ones, remember, because we can't see them, imaginary, okay? So the last ones, yeah, we probably could have gotten away with seeing on the x-axis. This one, we would not. Okay, so questions on doing synthetic division twice. Remember, it's not to the original both times. It is just continuing to break it down. We want to get it down to a quadratic. Okay. Let me see what else I got in here. Okay, let's try one more. All the way through. I've given you 2 of them. I need the other 2. So if you notice, I did 1 first. Just to show you, it does not matter which one you start with. Okay? A lot of y'all probably did -1 first. I just did 1. But at the end, that 12, that 30, and that -18, we should all have. Okay? Now, I'm probably going to make this one a little bit more easier on the eyes for myself, especially with bigger numbers. I know that all of these are divisible by 6, so I'm going to take it down a notch. Because for me, I might not be able to see whatever 12 times 18 is and find factors of that to get me 30. But I might see the factors of -6 to get me 5 or something a little bit more attainable. If you did quadratic formula, you would have gotten the same answer too. Okay? So, factors of -6 that get me 5. Oops, there we go. Are going to be that 6 and -1. Split apart the middle. And factor by grouping. So this is all a review from last chapter. If you still have questions on this, please let me know. It's going to haunt you. So I get x plus 3 and 2x minus 1, which mean my solutions are -3 and 1/2. So would I be able to see these in a calculator? Absolutely. If I plug this into y equals the original question, I would have seen the 1, I would have seen the -1, I would have seen the -3. I'd probably guess that the 1/2 is there, if not use the 0 function. Okay? But I want you to be able to know how to do these in case a problem like the last one shows up and it's imaginary and you can't just look at y equals. Okay? Any questions on these problems besides them being forever long? Okay. One last thing I'll tell you about, it's something called the remainder theorem. Okay. So what they're saying in the remainder theorem is basically this. There's some words you can write if you want to write words. But what you can look at is, let's do this, okay? Jonah, what I want you to do, guys got big. I want you to do this problem here using 3, do synthetic division to it real quick on your paper. Dane, what I want you to do, you have a calculator?
I mean, I've got one here.
Okay, that's fine. Okay, what I want you to do, while he's doing synthetic division,
Yes.
I want you to take 3 and I want you to plug it into x. You just said okay.
I know.
That's so typical. I teach some kids are like, yep, got it, and then they're like, wait, what just happened?
Well, I thought you meant like it was a thing. It wasn't.
Plug 3 in for x. That's your thing. Okay, while y'all are writing down this problem, I'm going to show both up here. Jenna, do you remember to put zeros?
Yeah.
Good.
There's another 2.
What'd you get?
90. Ish. Hold on. Oh, wait, that is. Sorry.
And there's a purpose of what we're doing here.
Yeah, okay.
What'd you get?
180. Ish. Don't quote me.
Ish.
Don't quote me. I did most of it up here.
That's what I got.
All right, Kylie, plug it into your calculator.
What? How do you get 23 and 0?
How'd I get 23?
Yeah, and 0. Something. Now,
Because I said 20 times 3 was 23. Like a fool.
okay.
So then, I hate this board that it's off like that. Okay, so then 60, so 182. Was that one of your ish ones?
Yes, that was what I said.
Okay. Wait, 180, and then that's 182. Okay. And you got 182?
Yep.
Okay. Let me show what I'm doing here on the board for people who might still be watching. I don't know.
bet
I know
Maddie's still
Caden's not
watching.
today.
Maddie is totally watching.
Yeah, Caden's not. He's done.
Maddie McCall is watching this video right now.
Probably not. Okay. So
I'll get a text.
when the remainder theorem is saying this, okay? It's easier when you put numbers to it, okay? The remainder theorem is basically saying if you did long division or synthetic division, your remainder is also going to be as if you plugged it in to the equation. So the remainder theorem is saying, hey, if you have a number and you plug it into the equation, the same answer you get there is also your remainder. Okay? That's all they're saying. And I think on your homework, if I am thinking correctly and not getting y'all confused with my pre-cal, they're going to ask you to do both of these to show you that they equal the same thing. Okay? So if you get 0 as a remainder, you would get 0 here, which means it is a 0 of the function. Okay, so that's why we need remainder theorem, just to kind of prove all those steps. But the remainder theorem is just basically saying, hey, you can do synthetic division or long division and get a remainder, or you can plug that number into X and you would also find your remainder that way. Okay? So it seems more intimidating than it actually is, but that's just all the remainder theorem is saying. Okay? Your homework is 5-4 in Canvas. And then, like I said, our test will be on Friday.